Thank you guys for joining today. As I mentioned, we are discussing the serverless and messaging topic in this episode. And last week we explored Azure functions for serverless and for workflow kind of automation functionality. We explored Logic App, but today we are going to explore the remaining component like a storage, queue, event grid, and event hub, and service bus. Before getting to the this messaging topic, we just need to understand what messaging and what is event. So the difference between messaging and event we need to understand. So normally the Microsoft given us some interesting example where if assuming like we have some video recording or audio file portal where everyone records the music and upload it, and that information goes to the system, and many people are in the app. Whenever the new file is added, they need to be notified. So for this simple example, for in the context of message normally used for whenever you have a front-end logic which is triggering, which need to be processed by business logic, but the business logic you don't want to get failed, or the it should not be get lost in the middle of process. Then you will try to use a concept called queue. So in the queue you are sending your messages. So the message is normally the raw data and produced by one or more component that is consumed by another component. So in this logic, like somebody is uploading a music file, that file is sent it to business logic. That business logic will be uploading into a system, and then as soon as it's uploaded, it is visible for the user as well as it has to be visible for others or notifying the others. So it's a full logic. In this scenario, the file uploaded by user, it sent it to a process, and process is handling, and that process is the message. So the actual file itself send it into a message for processing. But here the message will always expect the processor to process in a certain way. Whereas in the another concept called event will be like, it could be like, um, any system can generate a event. That event can send it to more of like a publisher kind of activity, and this will be subscribed by more than one people. But the subscribers are how they are processing, and whether they are processing or not is not cared by this initial publisher. And also it is not the expectation of the subscriber to process it in a certain way. It doesn't care. So it's a lightweight notification, and it is also used for the scenarios I mentioned, right? um, when the file is uploaded, but the audio file is uploaded by user, and all the other members need to be notified that there is a new audio file is uploaded, that sends in the event. So that event is actually published, that is consumed by maybe like a notification service which will be notifying all users. So in the context of messaging, we need to understand like the actual message and the event. When it comes to Azure, so before going to Azure, like we will have some question like, when do we use message and when do we use event, right? So normally this is the simple questions we need to answer. If you have expectation of communication to be processed in a particular way, then your answer is you need to have a message. If the process can be done in any way, or we don't worry about that, then it can be event. In the Azure, we have various services. We'll go one by one. The first item we can talk about the Azure Queue Storage. The Queue Storage is a service that uses Azure Storage to store large number of messages. Also, it's a secure, and it is available worldwide. We can access through REST components. Um, The service bus is similar to that, but service bus is more of like a message broker for enterprise applications. So, like retailing, insurance, or fintechs, those people can use enterprise level. They can consume service bus, and again in the queue itself, you have a topic. So again, queue and topic is similar to even but not same as. But when it comes to queue, you send it in the queue, that will be processed by someone else. But in the topic, you publish it, the particular message that can be consumed by multiple subscriber. um, the multiple components also can trigger to do their work. So imagine in the music sharing application, user is listening to a song, and once they completed that listening, the it has to be sent it to various sub process where it will update like a user history or in the current moment how many people are listening this song, or like they can generate any number of metrics report, right? So for that, the topic will be better option. Like as soon as somebody completed it, send it to topic, the topic published, and that can be consumed by various component within the system. And more of like the benefit of the queues, it's a reliable, right? Like as I mentioned, like when you send it in a queue, it is processed one by one. It's like a first in first out. um, at least it will be delivered and somebody is processing the other side. Whereas if you don't have any queue mechanism in application, how the request is processed, what is the result of that, we don't know. And sometimes it can get lost in the middle, but the queue will process properly, and we'll also have the history as well, like how it is processed and what kind of fail notification happened. Like in the modern technologies, if anything fail, you can put it back to the queue again, and again that will be processed in the next cycle. um, Again, similar to that, we'll have a question like when do we use topic versus queue, right? In case you need a multiple receivers to handle each message, then you use it service bus topic. Whereas you wanted to use one of, then you go with the service bus queue. At least one delivery process will happen. Also, this service bus queue, you can see like the growth larger than 80 GB, and it also can have your role-based access model, and handle messages larger than 64 KB. And these are the difference between the topics and queues. Then we'll like to touch base the Azure Event Grid. It is another service of Microsoft. The name itself, it is giving you, it is event based, fully managed event routing service. It's actually running top of the Azure Service Fabric. Um, it's supposed to most of the services as a publisher, right? Like in this diagram, you can see the event is generated by any cloud services or on-premise services. Cloud services which are sorry, cloud services are generating the event. Like it could be like the completion of some activity, or some trigger audit, any messages generated by these Azure services, which will be sent it to event grid, and then event grid will put it in the, basically it's like a publisher, and then the published message will go into consumers. It can be consumed by any event handlers. It could be Azure Function or Logic App, or another event hubs can process it. The event hub is similar to that, but it is in the context of big data, whereas this can be generated by from anywhere. I think we discussed very long back. Somebody was asking like what is the difference between and event grid and versus event hub. Just 1 minute. I think I have the notes from previously. In case you are expecting see the event hub is more of like a IoT or like telemetry scenarios where millions of records are generated by some devices or a process which need to be processed by consumed by someone else. Then all these event can be millions of telemetry informations can send it to event hub. Whereas event grid is more of like not like a telemetry, but it is similar event handling, but it is used for a specific purpose where system can um, generate it, like the Azure services can generate, that can be consumed by other another Azure services. Okay, I think these are the queue and event based services available in Azure today, and we just wanted to explore that. I have a quick demo to showcase like how we are going to create a queue and how we are going to process that. Before moving to that, is there any questions, specific questions for anybody? Because little bit theoretical today, so just want to know like whether you guys are following, what kind of questions you have.
Uh, Karthik, I have a question regarding that event grid and event hub.
Yeah.
So, and does that mean that event hub is mainly for handling, like, if we want to handle large amount of data, so at that time we'll use event hub, or?
So, for example, event hub and event grid, I think this is what I was referring in the last time we had a similar question. Event hub will not expect any response when it is published, right? Like from the IoT devices, it is sending to millions of telemetry data to Event Hub, but Event Hub will not send the response back to your IoT devices. Whereas Event Grid can HTTP request notification can be sent it back. So
Okay.
I think the main difference is this is the main difference. Only big data level, Event Hub is used, but the main difference, even hub will not be able to send any response back to the sender,
Okay.
whereas even grid can send the response back to sender.
Okay. But both will follow the publish subscribe model only, right? For
That's
you,
correct. Yeah,
okay,
that's
using
correct.
publish subscribe model only. Okay.
Yeah,
Okay.
this is more of like so this is the publisher and this is subscriber model. So publisher can be from any machine, um, any source, even source that can be sent it to even grid, and even grid can keep it in the even grid that can be processed by subscribers, any number of subscribers. So I think we had some logic very long back when we talk about the taxi service company. Yeah, here you can see here. Um, this is the purely serverless architecture, right? Yeah, web app in Azure, which is Azure Ready Connected B2C. Users can register and then they can look for a ride share. The full credit goes to the ride share app developed by someone in the community. I don't remember the name, but it's not copyright to us. So once the ride is like a driver and trips and passenger, once the ride is created, it is notified to driver and the trips is confirmed and also the notify the passenger. So that's why you have three different APIs. And then once the trip is connected, it all the information goes into event grid. Actually, the event grid is it can send back the response. Also, it is in the these are the people are publishers, and this side of the people are the consumers, the subscribers.
Okay, okay.
This
So
is
suppose,
one real-time example you can think of.
okay, okay. Suppose if any failure occurs,
Yeah,
so how we are going to handle it in event grid topic? Like, are we going to store that message somewhere?
yeah. In the event grid, you will have that mechanism.
Okay, okay, fine. Yeah.
Okay, so I think the demo I have today, like quickly to run through, um, we got some sample in the Azure portal. So basically, like a typical, when it comes to queue, like first we are going to create. Let me show you that sample which we are going to run through, which will tell you like what are the steps we are going to perform here. So normally for testing this Azure queue storage, we are going to have a first storage account, and then we are going to create some console app. That app will have a logic of creating a queue, sending the messages and deleting the messages. And to do that, the basic app is created, console app is created. Then we'll be adding some Azure storage client libraries. Once the client libraries are added, then you add a synchronized code. Within this code, you will have a create queue, insert messages, and dequeue messages. This is the demo we are going to test it today. First, I'm going to create my storage account. So first I go to the resource group and I say like I create this say rg underscore 1906 21 and then say not first typical to all the demo we just first create the resource group. Once the resource group is created, we are going to create some storage account. So within this I will create a new storage account. Then I'll give it to not theorem, same as the previous one. So once the storage account is created, because we are going to, if you remember, when we talk about the storage topic, we understand what are the storage provides. It gives you blob storage, queue, table. So one of the queues we are going to consume today. So once it's created, I can show you what is available within the storage, and then we can also work on the um, sample console application. So now the resource is created. You can here see here containers for blob storage and file share, queues and tables. So because the storage account comes with this by default, within that we are going to consume the queues. Um, because from the console apps we are going to call these queues, we need to collect the access key. So the access key from here, I'm going to collect it. And what I collected here will be used in the console applications. So next, I'm going to create console application. So I go to the Cloud Shell. Wherever you not able to follow, just to stop me there, and then we can continue. So I opened my Cloud Shell where I'm going to run some command. Sorry. So I'm going to create a .NET new console application Q app. I think I already have one, so I'll just create a new one. So the blank plain vanilla is created. Now I'm going to this path. So you so once I navigated to that particular location, I'm going to build this. And building, you just type like a .NET build, because it's a plain vanilla console application we created. We're just building, so zero error, zero warning. Next, we are just going to because we are going to interact with our storage account, we just need a Azure client libraries installed. Like normally in the Visual Studio, you have you add a NuGet package. So similar that I'm going to do a .NET add package storage queues. So once this package is added, now we are ready. So I'm just going to navigate to this path. So here you can see our console application is added and the default program.c is available. And within this, we are just going to make some changes. So we are going to add a support for synchronization code and creating queue, etc. So first thing we need to, this is already there. So if I just get the sample code and then explain, it will be helpful. So here we have the complete code because we added the namespace. In this one, we are adding a namespace for Azure storage. This is the main reason we added previous step, the packages. Once the package is added, we are adding a Azure storage namespace. This will be helpful to call the methods. So here we are actually calling the connection string. On the particular connection string, here we need to pass our key, the one I was showing before. So in the access key, you just take this connection string, pass it here. This will give you, so here we'll pass our connection string. Then it shows you like it is creating a new queue called a my storage queue. And then if you scroll down, you can see like insert messages. The queue, whatever is created, it is also inserting the messages. And this message, whatever the message we are adding, it goes into this queue. We can view that information either through Azure portal or from the command prompt, or there is something called Azure Storage account. Sorry, Azure Storage Explorer. During the storage demo, we missed it this. So basically, it is a small Windows client. It's called Microsoft Storage Explorer. Once you connect it to your Azure subscription, it will tell you, like I connected to my subscription, which is telling me what are the, if I refresh all, it will tell me what are the storage account I have. So here you can see the one we created in the demo, which is str190621. And if we go to the queues, currently it's empty. So because it doesn't have any queues, from the code we are going to execute. When we execute, a new queue will be added called my storage queue. And then the messages we can add it to that. So again, if you scroll down, you will have other methods like retrieve the messages in asynchronize. And in case you are trying to read the same message, then if the queue is empty, it will attempt to delete the messages. And all these try catch methods are giving you the error messages. The same thing, we're simply going to test it. So I just need to save this. And I need to pass the connection string here. Okay, save, and then we will come back. We are going to, in this command prompt, we are going to build this code. So .NET build again because we modified the code. So no error it says. Then I'm going to run .NET run first queue message. Okay, queue was created and the message is sent to that queue. So because I sent it one, I'm going to show you that whether it is visible. If I refresh all. You can see the queue is created and the first message is added. Through this storage explorer also you can add additional messages, or running the same command again and again will keep adding the messages here. So the session is going to end in 10 minutes. So we'll continue the session as long as it's going. Once it's disconnected, please rejoin. We'll discuss some even great topic as well. So now you have seen options available. So let me put it this way: like in the media application we are exploring, when somebody uploaded a audio file or video file, that media information that has to be visible for a user or upload service. So everybody is uploading and it has to go into the system. So millions of people or thousands of people are uploading, but how do you process it without missing any request? So that is why you need a queue. So you send it to queue, the queue will upload properly one by one. Once that is uploaded, then you are sending message back to the queue as a result. Like this is the outcome of that successfully uploaded, and that is one example. Then um, the apart from that, we also seen in the storage queue, you can create a queue and add messages that can be accessed via command prompt or object models. See here it shows the .NET object models you can access through C# course. You are actually creating a new queue using the Azure commands, and then you are inserting messages, deleting messages. This is just an example to tell you that your business logic can be implemented in a similar way. Like the technology is giving you option to put it in the queue and process it and delete it. If that makes sense. Do you guys able to follow this? Like what we have seen till now? Is there anything you would like to ask?
It's fine.
Okay, thank you. So I think the same way from the portal also you can view that. So if I go to the portal where I have this queue service, so my storage queue which I added, you can see that my first queue message is there. Then I can dequeue the same message. Like when you click, you see the full message when it is created in set time. You also dequeue, or you can also add through portal. Okay, sample. And it also has the expiry in 7 days. It can, this is configurable. You can keep it like how long this can be in the queue until it got processed. Okay, so probably like the next one I wanted to discuss with you guys for the event grid. Let me open that. So we are going to explore another example of, okay, not this one. Yeah. So this is the another example we want to explore today, which is about event grid. route custom events to web endpoint with Azure portal and event grid. So this is, as I mentioned, like event grid can be similar publisher and subscriber model, but it is not like a telemetry like a event hub, but this can be used for publish and subscription model. So in this example, they're actually using some of the topics. The topic is the public and subscription model. Once event grid topic is created, they're adding actual topic there. The topic will be accessed from the web endpoint. So that's also they're creating. So probably like what we can do, we can drop now, rejoin, and from that video we can continue the event grid demo, if that helps. Because the video also going to disconnect now, so we'll stop now and then join again immediately.
Yeah, okay, Karthik. Yeah.
Thank you, guys.